welcome to the video on guessing numbers, magic numbers. And before we get into the logic here, I want to show you something that I don't think I really stressed too much, and that is packages. See, I have what's within this project. You've been creating projects all semester long. Within this project, you could subdivide your code into chunks called packages. And inside here, a package is nothing more than you can think of a package as a directory, a subdirectory of all the classes that you would like to bundle together as a logical unit. Okay, and that's what I've done here. All my guess, I have 6 versions of guess number, and it just makes sense to put them into a directory or a folder or a package called guess number. And notice that guess number, the convention is the lowercase, the entire thing, guess number. But when you put things in packages, your code has to have a package statement that says, hey, this code is in a package called guess number. And so that's really it. If you don't have a package statement, you're going to have a problem. You're going to have a compiler error that says you're going to get an error there, right there. It's because you don't have, this code should be, is inside a guess number package, and you need to declare it as such. It's the same, it goes along the same lines as this code. Guess number version 1 has to be in a file called guess number version 1. It's a way to organize your code, and Java forces you to organize your code properly. Okay, so that aside, let's take a look at this. Let me run this program. And before we run it, what I'm going to do is, the idea is you're going to generate a random number between 0 and 100. And I don't know what that random number is, so I'm going to activate my little cheater so that I see what that number is. Let's run this now. See, the random number that got generated was 11. So, okay, let's see if we can guess that number. Guess a number between 0 and 100. Well, to do this game properly, you would say go in the middle, 50. Guess is too high. Okay, 25. Still too high. Half of 25 is 12. The next guess I would do is 6, but I'm kind of bored with this game. I'm going to go right to the 11 and say it took me 4 guesses to guess the number 11. Okay, so let's close that console out. Let's deactivate the cheater and see how we go about doing this. Well, look, you have to have a loop. You have to have a loop of some sort. Okay, this loop is asking you, hey, did you guess a number? Number got generated by the computer as a random number, no problem. Now we have that number established. Now we have a guess, and we need to guess. Okay, we need to prompt and guess the number. So you have to have another variable called guess, and every time you guess, you have to have I want to keep track of how many times it took me to get my answer. So I'm going to say count starts off at 0, and then I'm going to say count plus plus. So that's good. Now my while loop is asking the question, hey, is your guess not equal to the number? If it is equal to the number, hey, you found it. You're done. Don't do anything. That while loop shouldn't execute. But chances are you didn't guess it, so you're going to ask the question, hey, if execution comes here, you know guess is not equal to number, so it has to be bigger than or less than. So that's why I have this logic here that tells the person it's too high or too low. And then what we need to do is another guess, and then come back to then after we do another guess, we check the while loop to see if we've guessed the proper number. If it's not, if the guess is not equal to the number, then we do this logic again until guess is equal to the number. If guess is equal to the number, line 30 executes. You found the number. Yes, the number is number or guess. It doesn't really matter. And it took you so many times to guess the number. And this little logic here is just for the plurality. Okay. If its count is equal to 1, you write down guess. Otherwise, it's guess is. Okay. And then also I have some logic here to get you used to the system here. I have a little title, and I say welcome to the title, and at the end, thank you for using this program. See, run it. Welcome to the guess a number version 1, 50, Okay, I'm sick of it already. We're done. Okay. Program works. You should be happy with yourself. But then what you're going to say is, well, is there a way I can make this better? And there's always a way to make things better. Okay. The problem with this program is I'm duplicating logic here. See this code right here? Is the same thing as this code right here. It's the cardinal sin of programming to duplicate your code. Okay, so just sleep on it a little bit and see, hey, how can I eliminate that logic, that code? So what you would do is you take this, store it someplace, okay, because this is a working piece of code. If you can't get a more improved version, then at least you could submit the working version. Let's go with version 2 to see how we do this. Version 2 is basically this. Look, same thing. We're not going to talk about the initialization. We're just going to concentrate on this part here. I don't see any duplication of code. It's structured a little bit. The idea here is, hey, we have a while loop, and when you do a while loop, you need to make sure all the variables involved in the condition have to be initialized with a value of some sort. And well, we're starting off the while loop. I'll say that the guess is equal to -1. Well, -1 can't possibly be a number between 0 and 100. So I call that guess a primer value. That primer value starts the loop. So for sure, the first time through, that while loop is going to work. Is going to go through because the number is positive. Get -1 is negative, and they can't be equal. So enter your guess. Okay. Enter your guess, count it, and at this point we could say, hey, is it greater than? Is it less than? It could be equal. That's why I make sure if it's greater than, else if. Okay? If I don't execute these two parts, then it's equal, and we exit out of the while loop. Okay? So I don't have to check to see if it's equal in the loop. What happens is once we come back here, if it's equal, this whole while loop stops, and we can get to line 28, and you can print out the answer. The one issue I have with this is this primer value. It just kind of looks kind of hokey that we have to go out of our way to initialize a value to something just to get the while loop to work. So I have version 3. Version 3, same structure here. We have a little cheater. And this is basically the same thing as a primer, but I have another variable, keep guessing, Boolean. While when you start, you have to set it up to true because when you first start this, in a sense you're still priming, but it's just basically we just have a Boolean value that says, hey, as soon as we find the value equal to the number, we'll set it equal to false, in which case we want to stop guessing. While false, we'll exit out. Remember, while loops execute while it's true. So this is basically the same thing as before. We don't really have too much in the way of duplication, but I still have this other variable here that makes me a little bit ill. So let's see what version 4 looks like. Well, version 4 is great. Version 4 has no priming. What we have here is say, well, while true. While true. So that is a forever loop. So there's got to be a way to get out of that forever loop. Otherwise, you'll be in that loop forever. Okay? Because you can't make the word true into false. There's no condition that can happen. So we prompt a version for the person to say, hey, enter your guess. We count it. Hey, look at what happens here. If you guess the number, break out of the loop. That's typically what happens when you have a forever loop. Inside the loop, you have something that, and as soon as you find that something that you want to exit the loop by, we break out of the loop, and execution comes here. Now, if we get to line 24, it's not equal to the number. It has to be either greater than or it's less than, and we have this if statement that helps the person out. This is probably the one I would go for. I would gravitate toward this version here. But I have two other versions that we can look at. And basically a do loop. We haven't done too much with do loops. And this program really lends itself to having to using do loops because do loops execute their body at least once, and the condition is tested at the end. So we're going to fall right through. Okay, first time you have to guess at least one thing in order to get the answer, right? So we do the prompting, And basically, we have the same logic. If it's greater than or less than, we don't check for equals because this while loop, if you happen to be lucky enough to find it the first time, you're not going to output a prompt, but this while loop will be false. Okay, so we exit out at that point. So this is a little better. And the last one is number 6, where, you know, I take that back. Version 6 is probably the way I would go, because if I were to do this program, I would, in fact, use a do loop, because you have to execute your logic at least once. So I do so. I break out of the loop if it's equal to, if I find it. If I didn't find it, if it's bigger than, I output it's too high, otherwise it's too low. And basically, I have a do while true. It just stays forever. And just like we had before, if a condition's always true, there's got to be a way to exit the loop, and you have to have a break statement internally. This is the way I would probably code this problem. Okay, study them and study these versions, and we'll see you in the next video. Take care. Bye.